In sac203 number 1, they want us to find the electric field due to a positively charged particle. Let's go ahead and pop that in here. A positively charged particle, and they want it at some location, call it point P. Find the electric field at point P at a position directly below the charged particle. The particle in question has a charge 1.75 times 10 to the minus 7th coulombs. And I want to emphasize that this is the up direction toward the sky. So not northward, in other words. And this would be the downward direction toward the ground. That's just the way you're looking at it on this screen, on the computer screen. Toward the center of the Earth. So find the electric field at point P. We know, well, let's check on the direction first. Get the directions figured out. The direction of the electric field is the direction of the force that would be experienced by a positively charged test charge, a positive test charge if it was placed at that location. So let's put temporarily a little positive test charge just to check things out, and they would experience a force in that direction. And because of that, that means that at the point in space which is actually empty, we know the electric field is in that direction. Alright, that's the downward direction. So the direction, the answer to the problem as far as the direction is concerned is downward. So that's the electric field direction. That's actually one of the answers, or part of the answer to this problem. Alright, now we've got charged particle creates an electric field here at point P in the downward direction, and at this point we just need to find the magnitude of it. We can use what I call Coulomb's law for the electric field, which says that the magnitude of the electric field is kq over r squared, where k is the Coulomb constant, q is the charge of the particle that's causing the electric field, and r is the separation between the source charge and the empty point in space at which we're calculating the electric field. So r in this case is 0.250 meters. Distance from the source charge that's creating the electric field and the empty point in space at which we wish to know the electric field. So now it's just a substitution. E is the Coulomb constant K. You can look up on your formula sheet, 8.99 times 10 to the plus 9 Newton meter squared per Coulomb squared. And then times the charge of the particle. It was given as 1.75 times 10 to the minus 7th coulombs, all divided by the separation of the empty point in space and the source charge, which is 2.50 meters, and then that's got to be squared. So now all we have to do is evaluate that, and when I evaluate it, I get E is 25172 newtons per coulomb, or we get 3 sig figs in each of these values, so I should round it to 3 sig figs. I get E is equal to 25.2 kilonewtons per coulomb. And we did figure out the direction. It's the direction of the electric field is downward, so let's include that in our answer. Box that up. Say frame it. And